Hi friends, this is Rakesh Ranjan. Today we are going to discuss some basic elementary concept related with Java as a programming language. Many times I got requests from the beginners. Uh, they found sometimes confusing, sometimes difficult to understand the concept related with basic elementary Java. I am trying my best to simplify the concepts related with Java and with a very simple object-oriented program. I will try to demonstrate the object-oriented features and how the same will get implemented in Java. Not only theoretically, but we will try to implement the same in deeper, uh, not with very basic example, but we will try to take the industry standard example. So it will make your learning process little easy. When it's coming about Java, there are very good books available, and might be people are using the same uh, by Oracle Press itself or by different writers. I'm not going to specify the one or two writers or two, three books are there and all are very good. For the simplicity, I'm just taking the reference for Java tutorials available on docs.oracle.com. I have just opened this tutorial. The very first opening page is welcoming me with Java programming language basics. When you will focus on this Java programming language basics, the characteristics of Java on the high level, Oracle itself is documenting that it's a very simple programming language. It's having the object-oriented feature. It's having distributed architecture, multi-threading, dynamic in nature, architectural neutral, portable, the high performance, robust and secure. When I, as a practitioner of Java, trying to understand what is uh, the practical relevance of all these terms, so the many terms, sorry, of course, it seems little difficult to understand in the context of your day-to-day practices. So just with very simple example, I am trying to clarify the concept related with Java programming language basic feature. The first feature and second feature very easy to understand, and I will give more attention on the feature written on right hand side, that is architectural, neutral, portable, the high performance, robust and secure. So multi-threading, when we will start implementing, you will get to know how the multi-threading feature is happening. So simplicity means, as per Java documentation itself, that before the implementation of Java as a programming language, C programming language was there in existence. C++ programming language was there in existence. And C++ programming language terminology, the keywords, had exactly been taken in Java. So if a particular programmer who had good experience in other programming language, especially C++, they will found all those terms exactly in the same manner getting repeated in Java. Although Java is altogether a different programming language, so few keywords has been removed in Java. Java has not exactly taken the all the keyword of C++ or C as a programming language, but almost 80 85% the keyword are having the same relevance over here. Again, I am repeating, few keywords has been dropped in Java, so gradually I will explain all those keywords. Uh, in very simple context, that is the meaning for simple. So Java simplicity does not mean that it's a simple programming language and basically designed for doing the simple application development. Certainly, it's not like that. Simplicity over here, or the simple word here, means Java is a very powerful programming language, but very simple to learn, very simple to implement, very simple to write a code by using Java programming. So you can write a very complex program by using simple keyword. That's here the simplicity. Or the object-oriented feature of Java programming language. So Practically, we are going to dive deeper in object-oriented concepts such as abstraction, the encapsulation, the polymorphism, inheritance, how these features are getting supported by Java as a programming language, and altogether, what are these features? Uh, when we are taking one business case study into consideration, how these features are related with the case study and how the same will get implemented in Java, that I'm going to show you. Here, my primary focus is on architectural neutral. What is happening? What is there in Java as a programming language that making it architectural neutral? So when you will understand this particular concept related with architectural neutral, rest of the feature will be little easy to correlate. Uh, what is the architectural neutral and how Java is going to ensure that it will be architectural neutral. So what is happening in case of programming languages? If you are a programmer and you are writing a program in any programming language, let us assume C. So if you have written a program that is rakesh.c in C programming language, it will get compiled. After compilation, it will produce a file called rakesh.obj. In C programming language, it is called object code or object file. What is this object code? What is object code and what are the content in that object code? Further to that, when you will use the linker and loader and make this program executable, it will produce rakesh.exe. And finally, this will be the executable code. So, if you have written a C program and the size of this particular file, rakesh.c, is a very simple program, let us assume 10 kilobyte. If you have written few line of code and size of this program is coming to 10 kilobyte approximately, when you will compile the same to produce rakesh.obj, you will see that the size of this particular file is coming around 100 to 200 kilobyte. When you are translating the same to produce rakesh.exe, so rakesh.java, it will be compiled. After compilation, it will produce rakesh.obj. So I should put it over here. When you will execute it after linker and loader, it will produce exe after linking and loading. Now, what is happening in programming language? So, you have written a code. When you have written a code, let us assume very simple code like this, a very simple code. Although it's written in Java, but considering the same type of code you might have written in C. So, user requirement need to be translated to machine. So, while translation, if this translation of your user-defined code, rakesh.c, is compiling on Windows operating system, Windows 10 operating system, and it's getting translated on Intel PC of certain microprocessor. So what is happening during this translation? Your source code will get compiled. Whatever the user requirement you have written, that will get compiled into machine code. And in order to execute that, certain platform specific instruction. The platform specific instruction means how those user code will get executed on Windows operating system, on Linux operating system, on Intel processor, on other processors, or some other devices. So there are two things over here. One is user requirement, its translation, and another one is platform support to execute those translations. Now please pay attention. When you are writing program in C, all these are happening on user machine itself. So you have Rakesh.c written in plain English word. Finally, you got Rakesh.exe. If you will see size of this Rakesh.exe, so it will come to around 500 kilobyte or more. So I just have written 10 kilobyte of program, and when I am executing it, I got the size of that program got triple, 4 times, 10 times, depending upon the keywords what we have used and the platform on which that program is supposed to run. What is my point over here? When you are writing a program, you are just writing the few words related with your requirement. But in order to execute those requirements on the platform, many things are getting injected by the software, compiler, the linker, the loader, and other support software, which is really related with that platform. Now try to understand, if I have written this particular program for platform A, when object file got created, rakesh.obj, it's having the requirement related with my program and related with that platform also. Now, if Rakesh.exe is getting transferred from platform A to platform B, obviously on platform B it will not work because the requirement is same. My user set of instructions are same, but the platform has been changed. And at the time of compilation, compiler has injected the platform related instructions of platform A. It will execute on platform A, but on platform B it will not get executed. So the program written in C programming language, due to this total compilation, at the time of compilation, compiler is doing everything. So the program will be machine dependent. Now take the same example in case of Java. I have written Rakesh.java. When I will compile, after compilation, it will produce Rakesh.class. Here, rather than using the term object program, it's called bytecode. Now, Java compiler is very much careful over here. At this time, when Rakesh.java is getting translated to produce Rakesh.class, it's just translating the user written statement, user related requirement. All these terms what I have written that will get translated, and minimal stuffs related with the platform will get injected over here, minimal or no. So when program will get compiled, the compiler will produce .class file, that is called bytecode file. The bytecode file, the size of that bytecode file, if I will show you after compilation, you will see that that will be almost uh, uh, similar or little higher than what you have written. So if let us assume I have written this particular file, the size of this particular program is coming to 100 kilobyte. If I will translate the same, it will go for 200 kilobyte or 300 kilobyte. But it will be less than what you have experienced in context of C programming language. So what will happen over here, that at the time of translation, the translation will happen for user requirement, machine related instruction, the platform related instructions is still not injected to this particular class file. Now this particular class file will get transferred to runtime engine, and this runtime engine, which is called Java virtual machine, will translate those line of code again, and it will put machine related instruction to the bytecode, and finally my program will get executed. So if I will get opportunity to demonstrate you Java architecture, how the Java architecture is and how it will execute our program. Just taking randomly one example from net, one image to clarify the concept what I'm trying to say. So typically when it's coming to Java program, hope this image is visible to you. I have written the source code that will come to the Java compiler. The Java compiler will translate it to produce the bytecode. Now, this bytecode is not having much information related with the platform. It's just having the stuffs which is written in our source code, which is the machine code translation of this source code only, or you can say the binary translation for the written source code. Now this white code will be deployed to the system on which the destination where you are trying to execute your program. Now on every destination, every device which is executing the Java program will have one device installed in itself that is called Java Virtual Machine, JVM, or you can say Java Runtime Environment, JRE altogether. So the running environment destination system will have Java Runtime Environment, JRE. Inside JRE, we have three modules. Class loader. This class loader will load this particular bytecode program. After that, it will come to bytecode verifier. After that, it will come to Java Virtual Machine, JVM. JVM will do the line by line translation by using just-in-time compiler. And after that, this particular program will come for native operating system for execution. So, if you have written a program in Java programming language, after writing, you are trying to execute it on platform A, platform B, platform C, platform D. All these platforms will have different operating system, different hardware architecture. It can be different devices. It's not necessarily should be the computer. It can be any device. So all those devices will have a different JVM. So JVM are basically platform dependent. It's not platform independent. So for four different devices, you will have four different JVM. JVM A, JVM B, JVM B, C, JVM D. Whatever the program I have written, I need to write once. It will deploy to certain JVM. Inside that JVM, it will get translated. The machine specific, the platform specific instruction is there with that particular JVM. The JVM will put all those instructions and finally your program will get executed. So if the translation is happening like this. That's why the Java programmer always machine independent. Why it's machine independent? Because your translation is happening like that only. When you have written a code, your code will be deployed over there. And after deployment of the code, runtime system, runtime engine will inject the platform specific instruction. One more thing, friend, when it's coming about the Java programming, related with the other feature what was written over there, the security feature, the portability and the robustness, that in detail I will cover later. But see the architecture of runtime engine over here at the very high level. So first we have the class loader. So if we are running our Java program on a machine where the memory is limited, very limited memory device, so your whole program is not getting fitted or not getting loaded to the runtime engine. So this class loader will load certain specific portion of the program from where the execution will get start, and on demand it will dynamically load the other segments of your program, the other module of your program. So due to the runtime class loader, Java program is capable to show the dynamic loading of your stuffs. Uh, that will help you to maintain the runtime polymorphism of your program also, and it can be enhance the memory utilization of your programs also. Uh, when it's coming to the second feature, which is bytecode verifier, whatever the class loader has loaded before execution by the Java virtual machine, bytecode verifier will verify that particular bytecode. What is happening in this verification? Bytecode verifier is basically trying to understand that after execution of all these statements, is it going to produce any adverse impact on the critical section of your operating system or in your hardware? So is it going to do any security breach related with that particular platform? So JVM is specific to that particular machine. So on that particular machine or the platform, JVM is instructed that these are the sections where the sensitive, which are referred as sensitive area of our operating system or for our hardware. So of course, the user written program should not refer or should not manipulate all these area. That will vary from device to device, of course. So eventually that will vary from JVM to JVM. So that white code verifier is taking all the class which has been loaded, verifying that whether it's going to perform any impact on all those segments, all those area. If no, then and then only it will transfer to your Java virtual machine, which will use the just-in-time compiler. Just-in-time compiler is ahead the compiler, while your execution is happening for certain line of code. Just-in-time compiler in independent thread is taking another line of code and translating it. So each time making the translated executable code available for the execution. So just making the process very simplified. And finally, it interacting with operating system and program getting executed. So when one will focus on this explanation, so the robust feature and the secure feature and the high performance and portable feature of Java as a programming language automatically get linked with all this diagram, which is shown by the Java architecture itself. Hope this explanation will give you one idea how the Java program is getting translated, getting executed. See here, compiler has produced for JVM. All different platform are having different JVM. Now compiled code that is called bytecode will get deployed for different JVM. Now JVM will execute the bytecode verifier, and after that it will translate the program. After translation, the machine related stuff will get injected and your program will get executable. When it's coming about Java program, we have two components. One is Java virtual machine and other is Java application programming language API itself. So friends, I hope this video will help you to understand the basic terminology in a different perspective. Uh, Please be connected with me. In the next video, I am trying to my best to explain the same concept by using a very simple program. Thanks for watching.